Welcome to AMSA's webinar for construction barge safety. In the spirit of reconciliation, the Australian Maritime Safety Authority acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. My name is Claire Cunningham and I will be presenting this webinar on behalf of AMSA. AMSA has recorded this webinar after holding a number of successful workshops for construction barge owners and operators as part of a safety education campaign. This webinar aims to improve the safety of smaller construction barge operations. Today, we will educate you about your obligations regarding risk assessments with a focus on the risks associated with operating smaller construction barges. We will take a look at some of the key risks involved with construction barge operations and provide an overview of the regulatory requirements under the national law. First of all, I would like to provide a brief overview of AMSA, the Australian Maritime Safety Authority. AMSA has a number of regulatory functions and responsibilities. AMSA is responsible for safe shipping in international and Australian waters. AMSA upholds the requirements of international conventions on foreign flagged ships and also conducts flag state inspections on the Australian flagged ships, known as regulated Australian vessels. AMSA maintains a network of aids to navigation in Australian waters, such as many of the coastal lighthouses. AMSA provides a national search and rescue service utilising both maritime and aviation assets through the Joint Rescue Coordination Centre in Canberra, responsible for an area equivalent to 10% of the Earth's surface. AMSA is also responsible for pollution prevention in the marine environment. AMSA coordinates contingencies in the case of such an environmental emergency, including national stockpiles of oil spill response equipment, and has contracts and arrangements with towage assets in case of vessel breakdown. And of course, AMSA administers the national law. Prior to the national law, each state and territory had legislation which regulated their commercial vessels. Whilst there was a national committee who developed national standards, these were not adopted consistently across the jurisdictions. This meant that if you wished to operate your barge in another state, you may have needed to get it resurveyed. Also, crew may not have had their certificates of competency recognised in other states. The Marine Safety Domestic Commercial Vessel National Law Act 2012 replaces 8 federal, state and territory laws with a single regulatory framework for the certification, construction, equipment, design and operation of domestic commercial vessels inside Australia's exclusive economic zone. The national law commenced on 1st July 2013, with the first iteration having the states and territories delivering the services on behalf of AMSA. Then, in order to achieve a truly national system, AMSA took over service delivery on 1st July 2018. The introduction of the national law was part of a national harmonisation of transport regulation in Australia, which included domestic commercial vessels, heavy vehicles and rail. Next, we would like to show you a short video which highlights some of the consequences of when things go wrong on construction barges. This is a larger construction barge operation, but the risks are very similar. It happened in the Netherlands in 2015, and I would like to thank Studio Alphen for permission to show this video.
On the 3rd of August 2015, a lifting rig of a section of the Queen Juliana Bridge in Alphen aan den Rijn capsized. Both cranes and the lifted bridge section fell on the surrounding buildings. Many were completely destroyed. Miraculously, no persons were injured. Why did the lifting rig collapse? How did the parties involved assess the risks of this complex operation? And how did they manage the safety risks for the surrounding area? The Dutch Safety Board started an investigation into these questions. The municipality of Alphen aan den Rijn commissioned the renovation of the bridge to a consortium of a steel constructor and a construction company. The steel constructor hired a crane operator to lift the bridge section. The crane operator subsequently hired the barge operator. A large mobile construction crane of 700 tons on the first barge and a small construction crane of 400 tons on a narrower barge were deployed for this lifting operation. The intention was to simultaneously lift the bridge section from a third barge in a tandem lift operation. The bridge section would then be maneuvered in between the two cranes before being tilted into an almost horizontal position. The two barges would then sail 100 meters, where the bridge section was to be raised and fitted into the existing bridge structure. The crane operator and barge operator had worked together before, and they believed in the feasibility of the plan, as long as the work was undertaken cautiously and if ballasting of the barges would be done in time. Floating objects, such as barges, can move freely in water. The amount of movement depends on the stability of the rig. The more stability, the less movement, and the sooner it returns to its starting position. Stability is determined by the width and depth of the barge, and by the height of the center of gravity in the crane masts. The lifting rig as used on the 3rd of August, in particular the barge bearing the small construction crane, demonstrated insufficient stability and started to slope to such an extent that the mast of the crane failed, causing the crane itself to topple, thereby pulling the bridge section with it, which in turn also pulled over the large construction crane. The complexity of the lifting operation had been underestimated by the parties concerned. There was a lifting plan that failed on critical elements. The cranes were too high in relation to the width of the barges. In addition, several heavy objects were placed on deck, further reducing the stability. There was no margin to absorb additional forces caused, for example, by natural bending of the mast of the crane, the movement of the cranes, or a gust of wind. A relatively small movement of the cranes caused the whole construction to topple. The Dutch Safety Board recalculated the initial stability and concludes that even if the lifting operation had been carried out faultlessly, the accident could not have been avoided. The lifting rig was situated in the densely populated centre of Alphen aan den Rijn. The largest crane towered with 44 meters far above the surrounding buildings. None of the parties involved recognized that the lifting of the bridge section engendered risks for the immediate surroundings. Within the construction consortium, the construction company, as project manager, occupied a key role in coordinating risks. However, the construction company saw the hoisting of the bridge section as a responsibility of the steel constructor, and therefore not its own. Neither noticed that the lifting plan was inadequate, and they let happen that the lifting started with an unsafe rig. Safety focused merely on the workers and the construction site itself. The municipality of Alphen aan den Rijn attached considerable importance to avoiding additional nuisance for the local residents during the renovation work. When issuing the license for the renovation, the municipality could have demanded a construction safety plan for the area describing safety measures, but failed to do so. As a result, the execution of the work, including the lifting work and the related safety risks for the surrounding area, remained unconsidered. The Dutch Safety Board concludes that various parties blindly trusted on one another's expertise and relied on the responsibility of the other parties in the chain. This pattern was reflected throughout the project organisation, from barge operator through to municipal authority. The Dutch Safety Board has the following recommendations. To the construction companies involved, for future building projects, ensure that adequate risk management is performed for the entire construction process. To the Minister for Housing and the central government sector, ensure that any building project is designated one party responsible for risk management. Enlist in the building decree when a construction safety plan is needed.
I'm sure you will agree that it was amazing that no one was injured in that incident. It was also amazing that no stability analysis had been undertaken during the planning of that operation. And then, even if a stability analysis had been done, it would have shown that this incident was inevitable, even if everything went to plan. Another key takeaway is that there were too many people involved and all trusting each other's expertise without anyone taking overall control and management to assess the risks. This safety campaign was included in the 2021-2022 National Compliance Plan published by AMSA on our website. AMSA has been seeing an increase in incidents involving construction barges, and our investigations show that lack of up-to-date risk assessments and poor implementation of risk assessments has been a contributing factor. There have been 2 deaths involving construction barges over the last couple of years. We are also seeing poor risk management practices as common deficiencies in our inspections. This slide shows the common issues AMSA has observed through incident investigations and inspections. Next, I will touch on AMSA's regulatory requirements for construction barges. All domestic commercial vessels are required to hold a vessel certification. This may be either a certificate of survey or non-survey vessel permission. This certification is evidence that the barge meets design and construction requirements and determines the type and quantity of safety, navigation, anchoring, communication and fire equipment carried on board. If your barge holds a national law certificate of survey, it may be operating under General Exemption 41, which exempts unpowered barges from certain construction equipment and crewing requirements where it may not be practicable to comply. These exemptions depend on factors such as whether there are persons and/or machinery on board the barge. The standards your barge needs to meet also depends on whether it is an existing vessel, which means it was legally permitted to operate when the national law came into force in July 2013, or whether it is a new vessel under the national law. If your vessel is an existing vessel and you make certain changes, such as operate in another state or add a crane, the national law will consider it to have triggered to become what we refer to as a transitional vessel. The barge will need a new certificate of survey and be required to meet more of the current safety standards. Each domestic commercial vessel has a 6-digit AMSA issued unique vessel identifier or UVI. Existing barges may instead display a state or territory issued UVI. A unique identifier is a number that stays with the vessel for its entire life, even if the vessel changes ownership. Unique identifiers help to identify domestic commercial vessels, and this is the number you will need to use when you make applications with AMSA. The Certificate of Operation identifies the operations and operational area and requires all vessels to have a Safety Management System, or SMS, that meets the Marine Order 504 requirements. Other operational conditions may be placed on the certificate. Some small, less than 7.5 metre construction barges operating in sheltered waters may be exempt from a certificate of operation under a general exemption, but will still need a safety management system. The general safety duties have offence provisions attached to them and are very similar to workplace health and safety legislative duties. The general safety duties can apply to owners, masters and crew. It is important to note that the national law defines owner as both the legal or beneficial owner and also the person who has overall management and control of the vessel. The general safety duties include the duty to provide and maintain a vessel so that it is safe, and the duty to ensure the safety of the vessel, people, marine safety equipment, and the operation of the vessel. Construction barges are classified as domestic commercial vessels and must meet the requirements of the national law administered by AMSA, as well as the requirements of other regulators. These may include the requirements of local waterways management authorities, environmental protection agencies, and state and territory workplace health and safety regulators. Under workplace health and safety legislation, construction barges are defined as workplaces and must also meet specific workplace health and safety requirements with regard to risk assessments to operate safely. Generally, local waterways management authorities will apply requirements relating to rules of the road, including collision regulations. They may apply certain restrictions to ensure safe navigation, particularly in heavily congested areas and those waterways with hazards to navigation. You need to be aware of all of your environmental protection obligations and consider them when completing or reviewing your risk assessment. Your local environmental protection authority can provide more information. You need to be aware of the workplace health and safety requirements in the state or territory where you are operating. These requirements can include the requirements for high-risk work licences, such as for crane operations, what types of incidents you need to report to the workplace health and safety regulator, the timeframes for reporting, and the requirements to preserve incident sites, plant registration and inspection requirements, requirements for safe work method statements, and requirements for workplace health and safety management plans. Whilst workplace health and safety legislation is risk-based, some high-risk work activities are specifically regulated by workplace health and safety regulations and codes of practice. These can include falls from height, access and egress, mobile plant, emergency procedures, and trip hazards. AMSA has a memorandum of understanding with most of the workplace health and safety regulators to work together on both education and compliance and incident investigation, as we recognise that there are similarities and overlap between the regulatory requirements from both AMSA and WorkSafe authorities for domestic commercial vessels. Every domestic commercial vessel needs to operate under a safety management system, or SMS, that meets the requirements of Marine Order 504. There are a number of elements that need to be covered as part of your SMS, as outlined on this slide. However, the complexity of your SMS will depend on the complexity of your vessel and its operation. For instance, the SMS for a Sydney Harbour ferry or a tug would be expected to be significantly more complex and detailed than the SMS for a solo scale fisherman operating in sheltered waters from a 5-metre tinny. AMSA does not mandate a template to be used for your SMS. So if it works for your business, you can combine all or some of the elements of the SMS with your workplace health and safety documentation and requirements. You can also have an electronic SMS so long as it is backed up. And there are a number of commercial platforms offering these services. The key to your safety management system is your risk assessment, as it should determine the content of a lot of your SMS, which we will discuss further shortly. Another key part of your SMS is ensuring that it is clear who is responsible for what when it comes to safety. And most importantly, your SMS needs to reflect what you are doing in your operation. The benefits of a safety management system include an increased awareness of safety and everyone on board the barge understands the risks involved and how they can keep themselves and others safe. It also ensures everyone knows what to do in the event of an emergency. An SMS also provides evidence that if an incident does occur, you did everything you reasonably could to protect those involved. It can lower your exposure to costly and stressful legal action. There are many negative impacts as a result of incidents, including injuries and fatalities, and the impacts to family and co-workers. Compliance action can include fines or prohibition of vessels operating. You can be exposed to civil litigation and the loss of income and assets, and it can also impact your business reputation. If someone is injured on your barge, will others want to come and work with you? Construction barge operations present a variety of hazards and risks to safety which must be identified with controls put in place to eliminate or minimise these risks so far as reasonably practicable through a risk assessment, which is part of your safety management system. This will help everyone on board understand their safety responsibilities. The risk assessment is the cornerstone of the SMS. It determines the procedures and training that you implement. This webinar is not designed to teach you how to do a risk assessment, but we will provide advice on AMSA's requirements and expectations. This slide provides an overview of the risk management process. AMSA has a published risk assessment in the national system, a practical guide on its website, which outlines AMSA's expectations with regard to risk assessment. It follows the Australian standard for risk assessment. Construction barges undertake high-risk construction work under workplace health and safety regulations and are required to prepare a safe work method statement, or SWMS. Your SWMS may also meet the AMSA risk assessment requirements if it identifies and assesses the risks associated with the key daily tasks of the construction barge. As part of your risk assessment, you should assess the likelihood of the risk occurring. That is, the possibility that someone will come into contact with the hazard. You should then assess the consequences if the risk did eventuate. This includes the type and/or severity of harm that a person could sustain if they came into contact with the hazard. You can then use the risk assessment matrix to give the risk a rating. Once suitable risk controls are applied, it is useful to reassess the risk to see if the risk rating has changed. In many cases, the likelihood of a risk occurring will reduce when effective risk controls are in place. When completing your risk assessment, you should consider the hierarchy of controls, which is also referred to in workplace health and safety regulations. You should start at the top of the triangle with the most effective controls and then work your way down to the bottom. In most cases, personal protective equipment is the least effective as it will not prevent a risk eventuating. For instance, wearing a life jacket won't stop a person falling in the water, but it will improve the probability of the person not drowning. The engineering control of having appropriate guardrails are more likely to prevent a person from falling overboard. You can't eliminate all risks, and humans are not fail-safe, and accidents will happen, but you can control risks to reduce the likelihood and consequences of incidents. The legal test in both the national law and workplace health and safety regulations is the requirement to reduce your risks so far as reasonably practicable. There are guidelines published on the Safe Work Australia website with further information on how to determine what is reasonably practicable. It is most important that your risk assessment reflects what you are actually doing. Construction barges typically undertake a variety of operations which may include carrying and securing heavy deck loads, lifting heavy weights, powered mobile plant, or working at height. Your risk assessment must be reviewed every time anything on your vessel changes, whether that be a new location or a different work task. You must also review your risk assessment after any incident or hazardous occurrence and keep a record of your updates. Like your business operation, your risk assessment needs to be dynamic and respond to change. You can supplement your risk register with other risk assessment processes, such as a job safety analysis or the Take 5 process. These are particularly useful if something unexpected happens. Before immediately jumping in to fix an issue, undertake a risk assessment process to ensure people aren't going to be placed in danger. This is often when incidents occur. Make sure you keep a record of these risk assessments. Now we are going to have a closer look at some of the factors that can create high-risk situations on construction barges. AMSA considers stability to be a high risk and so needs to be addressed in the risk assessment for a construction barge. Basically, stability refers to the vessel's ability to return to its upright position after being heeled over by wind, waves, or other forces such as lifting loads or adding cargo. The flat bottom shape of barges mean they have unique stability characteristics which need to be considered when carrying loads and lifting weights. And AMSA has been observing poor practice in relation to managing stability on construction barges, and this has resulted in incidents. We'll take a look at some of the important factors affecting stability on construction barges. Construction barges may carry a variety of deck cargoes, such as building materials, wharfing piles, wheeled or tracked vehicles, and contained liquid cargo. The main risks associated with deck loads include the risks to the integrity of the deck and the barge itself, and also the effect on stability or reserve buoyancy of the vessel. You need to consider the internal structure of the barge and thickness and condition of the deck plating. As part of this, consider the concentration of any loads on the deck. Consider using dunnage to spread any concentrated loads across a wider deck area. Make sure you regularly inspect the deck plating and barge structure and monitor for any corrosion which may weaken the structure. Basically, the less barge there is above the water, the closer it is to sinking and the greater risk to the safety of the cargo and people on board. The distance from the water's surface to the deck is known as freeboard. The use of minimum freeboard marks is a really good idea and gives an easy visual reference to make sure the barge is not overloaded and has enough reserve buoyancy. You also need to ensure you appropriately secure your deck load to prevent it shifting, for instance, due to waves, weight from other vessels, or changes to the heel and trim of the barge during lifting operations. The movement of unsecured deck loads can cause a barge to rapidly capsize. Construction barges may have a fixed crane or carry a mobile crane or excavator. This may be used to lift deck loads on and off the barge or move objects outside the barge. Loss of stability is one of the key factors associated with serious crane incidents. Using cranes or lifting devices on a barge presents high risks from land-based operations, which must be considered and assessed as part of your risk assessment. One of the most important issues to note is that you cannot use the same loading graphs and calculations and radius diagrams for mobile cranes once you have placed them on a barge. These need to be reassessed by a competent person, such as a naval architect, and derated to ensure safe operations. When a weight is lifted by a crane, the effect of the centre of gravity of the lifted item rises to the point of the lift on the crane, as shown in this diagram. This can dramatically raise the centre of gravity of the barge and the crane. This will lower the stability of the barge, similar to the effect of standing up in a canoe compared to sitting down. You want to keep the centre of gravity as low as possible. Deck loads should be loaded to ensure the heel and trim is even. Excessive heel or trim reduces the area of the barge in the waterplane area, and it can quickly become unstable and capsize. It may also cause the downflooding of water into spaces below the deck. Things that affect the heel and trim include lifting operations and the loading and unloading of tractor-wheeled vehicles. If your barge is not sitting evenly in the water, when your maximum lifting and reach limit will be reduced. You must closely monitor the distribution of weight during loading operations. Bilges must be checked regularly and kept dry, as the flat bottom of a barge can create a significant free surface effect. A free surface, also known as a slack tank, is a body of water in a tank or a vessel that can slosh about. The presence of water in the bilges will invalidate a stability assessment. This diagram depicts what will start to happen when a barge is approaching the limits of its stability. Getting wet feet is a sure sign that the barge is running out of stability and close to potential capsize, as it relates to deck edge immersion. A barge is stable until it's not. You can see here the curve drops off quite sharply. When the chine of the barge comes out of the water, you lose stability very quickly after that, as the diagram shows. Key to managing the risks relating to stability is having a relevant stability assessment from an accredited marine surveyor. It is a requirement for all construction barges approved to operate after June 2013, including non-survey barges, which have a crane, deck load or lifting device installed, and this includes a mobile crane. Having an up-to-date stability assessment ensures you will not generate a heeling movement that may endanger or capsize the barge or exceed the maximum safe loading for the barge. This stability assessment will ensure you are using the right size barge for your crane reach and slewing impacts. Your stability assessment may include useful guidance such as the limited kg curve. The term kg refers to the distance from the vessel's keel to its centre of gravity, and it displays a line indicating the maximum height of the vessel's vertical centre of gravity for a given displacement. This can be further simplified for barges to display in terms of cargo mass and height above the deck. If the location of the centre of gravity for a given mass is below the curve, then this is a safe condition. A centre of gravity and mass above the curve is unsafe. Relocating a barge. Construction barges regularly relocate to different job sites by being pushed or towed by another vessel. Often heavy barges can be difficult to manoeuvre and susceptible to wind, current and tides. Relocating them creates a new set of risks that must be considered and controlled as part of your risk assessment. The towing vessel is a domestic commercial vessel itself and needs to meet the relevant national law requirements. It needs to be a suitable vessel in terms of engine power for the weight of the tow, have adequate stability, and its crew need to hold the relevant certificates of competency. There needs to be unrestricted visibility for the master and a method of communication with the crew. You need to consider the suitability of the tow arrangements themselves, including the suitability of tow points on the barge and the towing vessel, and the condition of tow ropes, bridles and wires. Also ensure you are displaying the correct day shapes or navigation lights. The crew involved need to have appropriate experience and training in towing operations and consideration given to the dangers of working near lines under tension. A passage plan should be developed which considers weather and sea conditions, navigational hazards, local waterways and port requirements, safe havens, fuel requirements, communications coverage, and emergency plans, including the ability to release the tow under load. Ensure the barge you are relocating is watertight. Keep hatches closed and bilges dry. Minimise the load and polluting substances you need to carry and make sure any load is secured. If relocating a barge outside its area of operation on its vessel permission, you will need to apply for a temporary operations permit and address these considerations. You need to provide safe access and egress to your construction barge whether this be from a wharf, marina, or another vessel. A gangway may be needed to prevent workers and crew from falling overboard. Any gangway or gangplank used needs to be appropriately secured and take into account tidal variations. Failure to provide a safe means of access has previously resulted in drownings. Consider the requirements for emergency evacuation in case of fire, explosion, sinking, or loss of stability. If this cannot be via the shore, then a standby vessel that can carry everyone on board may be needed. If you do not have compliant guardrails, consider other controls to minimise the risk of persons going overboard, such as the marking of deck edges, no-go zones, and the wearing of life jackets, which are mandatory in some cases. You need to have a person overboard plan and practice your drill. Consider whether you need a means of reboarding the barge, such as a ladder, and whether you have a rescue vessel standing by, particularly if there is current or tide, as time can be critical. Can you communicate with other vessels in the area, and do you have a life buoy at the ready to deploy? Key to managing risks on board construction barges is ensuring everyone understands the hazards and risks on board. You may have workers on board that are unfamiliar with the risks of working on the water. Marine Order 504 states that all persons on board a vessel need to understand the risks and how to safely carry out their assigned duties and respond rapidly and effectively in the event of an emergency. Practice your emergency drills so that everyone knows where critical safety equipment is located and their role in the vessel's emergency plan. For instance, do your crew know where your fire safety equipment is and how to use it? Fires can spread very quickly. You need to record the induction and training within your safety management system, ensuring that it is signed off by those who have undertaken training and by those who have provided the training. Keeping a record of certain things such as inductions, training, reporting and investigation of safety concerns and updates to risks and how you manage them shows your commitment to actively identifying opportunities to improve safety. Remember, it is one thing to have a good safety management system and its documentation, but it is only of limited value if it is not put into practice. In this incident, which happened in the Northern Territory, a barge was moored in a different location than usual. The barge was being used for accommodation at the time, and a crew member was attempting to reboard the barge at night, but slipped and fell in between the wharf and the barge, suffering several fractures, and was found deceased in the water the next morning. As you can see, the means of access was clearly not safe, and in this case there was a safe work prosecution with significant fines. By reporting marine incidents, you are not only meeting your legal obligations, but it assists with the development of more effective safety education and advice to avoid similar events in the future. You will need to submit a Form 19 to AMSA. This can be done through an online form or email a copy through to AMSA. One of the most important parts on this form is the part which asks you what actions you are taking to prevent a reoccurrence of this incident. The information provided assures AMSA that the owner, operator and master understand the safety issues that contributed to the incident and have implemented measures to learn and prevent reoccurrence. If it is a serious incident, you will need to first submit a notification to AMSA of the incident as soon as possible, and this can be done using the Form 18 on the AMSA website. The detailed follow-up report of the incident must be submitted within 72 hours through the Form 19. AMSA has been carrying out focused inspections of construction barges during May and June of this year, with inspections of 100 construction barges nationally. These inspections have been carried out jointly with workplace health and safety regulators where possible. These are the questions that AMSA has been asking during these focused inspections. As you can see, they all relate to the material covered as part of this safety campaign and are available on the AMSA website. Further information regarding this campaign and the material covered in this webinar are available on the campaign website. Resources that have been developed include an example risk assessment, a risk assessment safety checklist, and a range of frequently asked questions. You can also order a BARGE safety sticker. Please also visit the AMSA website for a range of information on operating domestic commercial vessels, and call or email AMSA Connect with any queries. Thank you for your interest in this webinar.